This is a video from section 12.1, and it's based off the lecture notes. A sphere with radius r and center HKL is defined as the set of all points x, y, z whose distance from HKL is r. XYZ is on the sphere if r is equal to the square root of x minus h squared plus y minus k squared plus z minus l squared. So in other words, suppose we have the ordered triple HKL. Remember, that's the center of the sphere. And suppose this is the ordered triple XYZ right here. So we're going to look at the distance between these 2 points in 2 different ways. One, we're going to call the distance between these 2 points r. And then we're going to apply the distance formula to find the distance between these 2 points. So notice how on the left side we have r, and on the right side we applied the distance formula. Now what we want to do is square both sides. And when we square both sides, we get the equation of a sphere. So the equation of a sphere is x minus h squared plus y minus k quantity squared plus z minus l quantity squared is equal to r squared. The center is HKL and the radius is r. Now, one thing I'd like you to note is if the center is 0, 0, 0, the equation of a sphere becomes x squared plus y squared is equal to r squared. So it's just a special case. Now, let's take a look at example 1. Find an equation of a sphere that passes through the origin whose center is 1, 2, 3. So we really want to be aware that the center is 1, 2, 3. It's human nature to think automatically that the center is at the origin. But remember that in this example, the origin is on the sphere. The center is right here. Okay? Now, in this example, h is 1, k is 2, and L is 3. So the equation becomes the following. X minus 1 quantity squared plus y minus 2 quantity squared plus z minus 3 quantity squared is r squared. And r is the radius of the sphere. Now what we want to do is solve for r squared. But remember, we know that 0, 0, 0 is a point on the sphere. And so I'm going to replace x with 0, y with 0, and z with 0. And we can now solve for r squared. Because remember, 0, 0, 0 is a solution to this top equation. So 0 minus 1 quantity squared plus 0 minus 2 quantity squared plus 0 minus 3 quantity squared is equal to r squared. And so that says r squared is equal to 1 plus 4 plus 9. But 1 plus 4 plus 9 is 14. And so that says r squared is equal to 14, and we're done. And so the equation becomes x minus 1 quantity squared plus y minus 2 quantity squared plus z minus 3 quantity squared is equal to 14. And that's example 1. Example 2. Given x squared plus y squared plus z squared is equal to 6x minus 4y minus 10z. Show that this equation represents a sphere, and additionally, we want to find the center and radius. And so what we want to do here is what's called completing the square. So we have x squared plus y squared plus z squared is equal to 6x minus 4y minus 10z. Now, I'm going to collect the x terms together, the y terms together, and the z terms together. So in other words, I'm going to group them in that particular order. So I'm going to get x squared minus 6x, and if you don't mind, I'm going to put parentheses here, plus y squared plus 4y plus z squared plus 10z, leave a little space, and we're going to set this equal to 0. Now, this is what we're going to do. What do I need to add to x squared minus 6x to make a perfect square? And I claim we need to add 9. Why? Because remember, half of 6 is 3, and 3 squared is 9. And then I'm going to go y squared plus 4y, right? So in other words, I have x squared minus 6x plus 9 plus y squared plus 4y, and I'm asking myself the same question. What do I need to add to y squared plus 4y to get a perfect square? And the answer is I need to add 4, because half of 4, right, is 2, and 2 squared is 4. So I'm going to add 4 here. Plus z squared plus 10z. And then remember, half of 10 is 5. 5 squared is 25. So I added 25 to get yet another perfect square. But I can't just do that because I changed the equation on you when I just add 9, 4, and 25. And so since I added 9, 4, and 25 to the left side of the equation, I got to add 9, 4, and 25 to the right side of the equation. So I'm going to put 9 plus 4 plus 25 over on the other side. And that makes it really nice because I could write this as x minus 3 squared plus y plus 2 squared plus z plus 5 squared. That's the left side. On the right side, we get 9 plus 4 is 13. 13 plus 25 is 38. So I'm going to do one more thing. So I'm going to write this as x minus 3 squared plus y minus negative 2 squared, right? So the quantity is squared, right? Because notice here, y plus 2 is the same as y minus a negative 2. And then similarly, I'm going to write plus z minus negative 5 squared is equal to 38. Why did I do that? This, first of all, is the equation of a sphere. So notice here in this example, h is 3, k is negative 2, and z is, not z, we're going to call it L. L is negative 5. So the center is 3, negative 2, negative 5. The radius is the square root of 38. And I'm done with this example. So this top equation takes on the form of a sphere. That's how you would show it's a sphere. And then when I wrote it in this format, it was easier to pick off h, k, and l. So that's why I did it that way. Now, let's take a look at example 3. same type of question. It says, given 4x squared plus 4y squared plus 4z squared equals 16x minus 6y minus 12, show this equation represents a sphere, and then it says find the center and the radius. Now, so what I'm going to do first is I'm going to collect, or I should say group the x terms. So I'm going to write 4x squared minus 16x, okay, plus 4y squared plus 6y. So group the x terms, group the y terms. And I'm going to add 4z squared, and I'm going to leave negative 12 all by itself on the other side. Now, I want the coefficient of x squared, y squared, and z squared to be 1, because that's what we need to complete the square. So I'm going to divide everything by 4. So every term gets divided by 4. Just like this. And so we get x squared minus 4x plus y squared plus 6 over 4 is 3 halves, so we get 3 halves y, plus z squared is equal to negative 3. Okay? Now, it's not perfect because we have 3 halves for the coefficient of y, but this is still a better position to be in. Now, from here, we're going to rewrite this equation this way. So we have x squared minus 4x, I'm going to leave a little space, plus y squared plus 3 halves y, again, leave a little space, plus z squared equals negative 3. So what do I have to add to x squared minus 4x to get a perfect square? And the answer is I need to add 4, because half of negative 4 is negative 2, and when I take negative 2 and square it, I get 4. Now, here, let's come over here for a second. Remember that half of 3 halves is equal to 3/4, right? And if I take 3/4 and I square it, I get 9/16. So I'm going to add 9/16 here, and I claim that I'm going to get a perfect square. Okay? But remember, you can't just do that. You can't just add 4 and 9 over 16 to one side of the equation without adding it to the other side. So in other words, I'm going to add 4, and I'm going to add 9 over 16 to the other side of the equation. So I get x minus 2 squared plus, and I claim this is y plus 3 over 4 squared plus, and if you don't mind, I'm going to write this as z minus 0 squared. That's on the left side. On the right side, we get 1 plus 9 over 16, which is 25 divided by 16. Okay? From here, we get the following, and we'll come over here. So we get x minus 2 squared, right? Plus y minus negative 3 over 4, because I'm making it look like a sphere, right? So I'm taking y minus a negative 3 over 4, and then I'm squaring it. And then I'm going to add z minus 0 squared, and I'm going to set this equal to 25 over 16. So this equation, and I hope you guys can see that okay. This equation, here, let's try that again. Here, let's write this a little clearer. So we get x minus 2 squared plus y minus negative 3 over 4 squared plus z minus 0 squared. And this is 25 over 16. So this equation represents a sphere, right? It fits that form. The center is going to be 2, negative 3 over 4, 0. The radius is the square root of 25 over 16, which is equal to 5 over 4. And that'll conclude this video for section 12.1, and we focused primarily on the equation of a sphere and worked out 3 examples. Thank you.